Hello, fellow tricksters. Let's talk about boundaries. Today, the tool we're going to use to explore boundaries in code is called the Law of Demeter. There's going to be resources in the description telling us more about the Law of Demeter. I'm going to give a short explanation in the video so we can move on with an actual example so you can see it in practice. The Law of Demeter says that an object is not allowed to reach into another object it is working with and deal with such a nested object. The word that the law of Demeter uses is the collaborator. That is to say, an object inside another object is a collaborator of that object. Enough abstract wording. Let's go to an example. Let's take a look at a simple small project where a company will send snail mail to other companies. If you're not familiar with the expression, snail mail is just physical mail, mail that goes through the post, mail you get in your mailbox, as opposed to emails. So here is what the entity relationship diagram looks like. It's very simple. We're going to have the snail mailer, the object responsible for actually sending the mail. It will interact with one or more companies. Each company is going to have one or more addresses represented by an address group, and then each address group will have the actual addresses. So let's take a look at an example of code written incorrectly that violates the law of Demeter. Here is what this would look like from the bottom up. An address is very simply an object. We are representing it just as having a street. It would, of course, have more properties, but they're not relevant for the example. So this will keep the code more compact as we go through the example. An address group is going to be equally simple. We are going to have something here that is going to be your first indication of something possibly going wrong. Conversation we can have later, you'll see that the mailing address is coded as being the first address in the list. This should strike you as being terrible. And that's correct, it is terrible. But that's not actually the main problem we're going to have to deal with. But this will come into play. The company will have an address group. It could have more than that property, of course, but again, keeping the code compact makes it easier to read. So now we're going to look at the actual object that will send mail. This will be slightly bigger, but not that much. This is a class. It's going to have a list of recipients when you instantiate it, and when you call the object, when you execute the code that is there to execute, you are going to retrieve all the mailing addresses from the recipients, and then you are going to batch mail catalogs. Batch mail catalogs is code that is not written, but it would actually execute the mailing of the catalogs, like the physical mailing catalogs. So let's take a quick look at how this might be used to give us a sense of all these objects working together. And then we'll come back to this object because this is where the violation happens. So this is how everything would get used. You would instantiate both addresses, mailing and shipping, or however many the company has. You would create an address group with both mailing address and shipping address. Then you would create a company that has this address group. And then you would pass the company as one of many recipients, possibly inside the snail mailer. Here, again, for the sake of simplicity, we have one company, but there could be many recipients of these catalogs. So, okay, let's go back to the snail mailer and see what the violation is. The violation of the law of Demeter actually occurs on line 10. You can see it here in recipient.addressGroup.mailingaddress. In order to understand that this is a violation of the law of Demeter, we have to understand that the relationship between the entities in the entity relationship diagram is not the same as the object relationship diagram. So if we go back to the entity relationship diagram for a second, see here, snail mailer, company, address group, and the addresses. However, in order to keep the code changeable and manageable, The objects are really only allowed, according to the law of Demeter, to deal with the objects that they are directly interacting with. So this is what this would look like. We would have here, snail mailer is only allowed to interact with the company. That makes a fair amount of sense from the law of Demeter perspective. Then we would have the company is only allowed to interact with the address group. Then you can probably guess that the next one is that the addresses are only allowed to interact with the mailing address and shipping address. So if we were to draw the violation of the law of Demeter in the same type of diagram, it would look like this. Now we have a snail mailer, but the snail mailer is interacting with the addresses through the address group inside the company. And this is a problem because it means that the API of addresses and maybe even the implementation of the address class itself are now things that make the snail mailer hard to change, things that are hard to change because the snail mailer depends on them. So let's take a look at what this would look like with a better relationship between the objects that doesn't violate the law of Demeter. And then let's take a look at what this allows us to do. So if we were to take a look at these objects, we would find that the address does not change. The address does not need to change. It's just a street or practice more. The address group still doesn't change. But now we will see it will be allowed to change. We still have this kind of bad implementation here of addresses.first being the mailing address. And we'll talk about that in just a minute. But the company now has changed. The company now has a mailing address that is directly implemented on the company itself. And now it itself is dealing with the address group, which is its collaborator. So we are creating a boundary. Everything that touches the company and everything the company touches. So now if we look at the snail mailer is going to change. You can see it on line 10, simply by no longer having to call out and through the address group. And another reason why this is convenient is because if you had more than companies as recipients for this catalog, all they need is to have the interface of the mailing address. So all you have to take into account is if you passed recipients that weren't companies, they could be individuals, they could be anything, as long as they implement the mailing address, you can pass them into the snail mailer and it will just work. So this is used, you might realize, not very differently. The code here is exactly the same. But here's some of the magic that we can see. Now, I'm going to go back one more time just to see the main code of the snail mailer here. Now that we have recipients.mailing address, we are free to make changes beneath this and no longer be affected at this level of code. So if our snail mailer were still like this, now we could take a look at the company and realize that the company doesn't have to change, but it can if it needs to. We can look at the address group. Here, we're allowed to see changes because now we're allowed to implement the address group however we want. We can initialize it with internally an empty array of addresses, and then we can create a domain language around the address group where we define what it means to add a mailing address or a shipping address with constants representing symbols. And then when we want to get the mailing address, we can implement this however we want. In this particular case, we're now filtering through the array, looking for the first address that is of mailing type, and then we're returning the address object. And we could implement this however we want, and that is the point. The snail mailer is not affected. The company still gets what it needs, an address object, so these APIs are not impacted. And as you can probably guess, the address has not changed. The address is still what it is. And the only thing that has changed now is how we instantiate the address group. The address is the same. The address group is really the same. But now when we add a mailing address and add a shipping address, we do that explicitly in code. The logic around what makes a mailing address or a shipping address is not contained within the address, because an address is just, it's just information about how to find something on the map, right? From a human perspective. But the company can have an address group now that has a relevant, meaningful way to reason about these addresses. And the snail mailer, again, does not have to change at all. We just need an object or multiple objects that respond to the particular API defined in the snail mailer, right? Mailing address. That's it. So another way to consider this is that the message diagram represents a much more limited way of expressing the domain through the language that is different from the entity relationship diagram that is allowed to exist and needs to exist in order for the code to be well separated. In other words, because you have knowledge of the entire code base does not mean all the objects are allowed to as well. Hey Tricksters, thanks for watching. If you like this, smash that like, subscribe, and consider donating so I can keep making content for you. See you all next time.